As of now, we have discussed about convolutions on 2D image. Now we will discuss how to do the convolution on 1D and 3D volumes. Until now, we have considered a 2D input image. Height and width is 14 by 14, and we are taking the filter 5 by 5. Then we will get the output 10 by 10 output. If we have more number of channels in the input, example, if we are taking an RGB image, then it is 14 by 14 by 3. Then the filter also we have to consider 5 by 5 by 3. If we take 16 such filters, example, then output will be 10 by 10 height and width, because 14 minus 5 9 plus 1 10, and because we have considered 16 filters, number of channels in the output feature map is 16. Now we are applying the same thing for the 1D. In the 1D example, when we are taking the ECG, that ECG is an example for 1D. Here every time, this is the time series signal, the heartbeat, how heartbeat is taking place, that will be represented here. That the example, we are having 14, instead of 14 by 14, we are only having the one dimensional information 14. And now we have to consider the filter. Instead of 5 by 5, we are considering only the filter 5. So when we are convoluting this 14 with the 5, the output will be as usual 10. Means now we are convoluting this 5 with initially here, and then we are shifting with the stride. So this is how, if we have more than one filter, example, if we are having 16 filters, then output will be 10 by 16, where 10 indicates the 1D information, 16 indicates the number of feature maps. Now this 10 by 16 output we have given the feature map output. Again, we are convoluting with a filter 5 by 5. Instead of 5 by 5, that is 5 by 5 is 2D filter, we are convoluting now with the a filter with the 5, 1D filter with 5. And because we are having 16 channels in the input, we should also consider the filter with 16 channel. This time we are considering 32 such filters. So output will be 10 minus 5 plus 1, 6, and 32 channels, because we are taking the 32 filters. In the output, we are having 32 channels. Now, how do we perform the convolution on 3D data? Example, here we have considered the CT scan. Now we want to perform the convolutions on 3D data, or example on the CT scans or movie clippings. On that, we want to perform the convolution. At that time, we are taking the 3D volume. This is the 3D volume, and we are using a 3D filter this time. Now height and width and depth also comes into picture. This is height and width and depth, and we are convoluting with the filter 5 by 5 by 5. Then output will be 10 by 10 by 10. Number of channels, we are using only one. We are using 16 such filters, 5 by 5 by 5. This filter is also 3D filter. Then output will be, output feature map is 10 by 10 by 10, and we are having such 16 such feature maps. Now we are convoluting this again with the 5 by 5 by 5. Then we are using this time 32 filters. Then output will be 10 minus 5 plus 1, which is 6 by 6 by 6. And because we are using 32 filters, the information will be so output will in the output we are having 32 channels. This is how we apply the convolution which we learned for the 2D. We can apply even for the 1D time sequence signals, time series signals, and for the 3D example, for the CT scan or video information, we can apply this convolutional neural network.